Section 3.4, Part 1, Library of Functions. In this section, we're going to review various functions, most of which you've seen before in previous courses. These are basic and common shapes that you're going to see as well in this class, and we're going to build on this library of functions in this course. We're going to build the different types of functions with which you're familiar. We're going to use the terminology that we've studied in this recent sections: increasing, decreasing, even, odd. You already know domain and range of all these different types of functions. So we're going to start with the linear functions. The first three are all linear functions. The second two, these two, are special types of linear. So we'll start with just a general linear function. So the equation of a linear function, we know linear looks like line, has the word line in it. So the equation of a line, f of x equals mx plus b. So that should look familiar from previous classes. Obviously, its shape is a line. So when we're looking at the graph of our mx plus b, recall that the m is the slope, and the b is the y-intercept. So here's an example. Here's our b, our y-intercept, 0b, where it's crossing the y-axis. And this line, because it slopes up as we move left to right, we know it has a positive slope. M is greater than 0. So this is just an example. So the domain of a linear function, we can see that if we trace left to right, these lines are going to cover all the x values. So negative infinity to infinity in interval notation. And same with the range. The range is going to cover all the y values. So negative infinity to infinity. Now because this line, this is just an example of this line could look like this, it could look like this, there's all different shapes of this line. We can't determine even or odd, it's not applicable here. And then as far as increasing or decreasing, that depends on the slope. So the way that this example is drawn, it has a positive slope, so it's increasing everywhere. So we say that the graph is increasing if the slope, m, is positive, greater than 0. If we have a negative slope then, so if m is less than 0, then it would be a decreasing function. So it depends on the slope. Okay, a constant function. So this is a specific case of a linear function. So the general form of a constant function, like it sounds, is f of x equal to some constant, and we'll call the constant b. So an example here, here's our point 0b, and this horizontal line goes through it. So our shape of a constant function is a horizontal line. We can see its domain would be all real numbers, negative infinity to infinity. Now the range, because it's horizontal, the y value doesn't change, it's constant. So anywhere we go on here, the points are going to have the same y value. So the range is only whatever that b value is. So if this was 0, 5, your range would just be the y value 5. So in this case, it's just going to be the y value b. And in interval notation, we're going to use set notation here to indicate just that one specific value, b. So it's not an interval of values, it's just that one value b, and when it's one discrete value, we use the squiggly brackets, the braces around that. Okay, as far as even or odd, we can observe symmetry with respect to the y-axis here. So that tells us that this function is even. Constant functions are even. And then increasing and decreasing, because it's constant, it's neither increasing nor decreasing. Okay, our final type of linear function, another specific case, is the identity function. So that's a function in the form f of x equals x. So its identity function, it's named that because when you input an x value, you're going to output that same x value. So if I plug in an x in this function, the f of x value is also going to be x. You're going to get that same value out, so you can think of it as retaining its identity. So the shape of f of x equals x, so we know that if we wrote that in mx as mx plus b, that's like 1x plus 0. So your slope is 1, and your y-intercept is 0. So if we graph a line with a y-intercept of 0 and a slope of 1, so here it goes through 0, 0, we rise 1, run 1, rise 1, run 1, and that would give us this line. So we can see it's cutting through the quadrants at an exact 45-degree angle. It's slicing through diagonally. So our shape is a line with a slope m equal to 1 going through 0, 0. It's y-intercept. So we can see its domain is all real numbers, negative infinity to infinity, as well as the range. Now, as far as even and odd, we can observe symmetry here with respect to the origin, the rotational symmetry. So if we rotated this paper 180 degrees, we can see we'd have that same shape right on top of itself. So you can see kind of that diagonal looking shape. So that tells us this is odd. And we can see that it's increasing everywhere we go. If we start with our pencil all the way left, everywhere we go it's increasing, because it has that positive slope of 1. So it's increasing everywhere it exists, which is everywhere from negative infinity to infinity. So it's decreasing nowhere.